Hello, everyone. In this case, we are going to consider the factorization of the sum and difference of two cubes. So this part here, remember I explained this one from another video, which is the introduction. So most of you guys had questions. So I'm going to answer those questions that were having some complications. So we had also this question, which was number 3 on our exercise 11. This was question 3. So also, you must understand here that the factorization, when you apply the sum or the difference of two cubes, this part here, guys, you must memorize it. You must know it. It is just like the difference of two squares. All right, let me put it that way. X squared minus y squared, the difference of two squares. You know that you're going to have x minus y, one bracket subtracts the other one is gonna add the square root of what? Of these squares. So it's gonna be x minus y, another one x plus y. The order does not matter. Where is this one coming from? You are just given this is a difference of two squares. Then from there, you have to work with it, apply it, memorize and apply it to say, okay, if I see something like a squared minus 25 squared, I must know that I'm supposed to rewrite in that format so that I'm going to have two brackets. This is the same when you are to use the sum and difference of two cubes. Find a way of knowing these. Either you're going to memorize, you're going to find a song that you're going to sing in order for you to understand. I don't know. I do not know. Find a way. That is why I was referring to that part of the first term and the last term to say maybe if we can put it that way, to say the first term, then we have got the last term. So we've got the first term to the exponent of 3, last term to the exponent of 3. When being added like this, we are going to have the first term adding the last term. So it's going to be the first term plus the last term. Another bracket, we are going to have the first term squared minus the product of the first and last. Here, take note, this is the product of the first and what? Last term. So we've got the first term multiplied to the what? To the last term. Plus the last term squared. Y there being what? The last term. Y squared. So it is the last term squared. This is the concept. All you just need is to know which one is your first term. Then you memorize this. So if you can take it that way, it can be easier. So this is another thing that we are also having on this part when it is a subtraction, is still the first term to the exponent of 3 minus the last term to the power of what? To the power of 3. So we are going to have these condition x minus y, which is the first minus what? The last, just like what we had. First minus the last. We have a minus, so this is going to be a minus. Then here, we just have the same condition, just like the previous, only that it's going to be a positive. But here it is the first term squared. The same first term here times what? The last term, then plus the last term squared, just like before. So where do we apply this? The moment we are given these exponent of 3, as long what you are given there can be written as a term raised to the power of 3 plus another one to the power of 3, or it is a minus. then you can apply this concept or this one. So on question 3, which is a request that I said we're going to work with, we were given 64 x to the exponent of 3 minus y cubed, like that, all right? What can we do? Because what we need is to properly see two terms. As we have a subtraction, so we're going to use this part. So we must have a certain term. As we can see here, it is 64, and there is x to the exponent of 3. 64, can it be written as a number or a term to the exponent of 3? Is it possible? 64 is same as 4 to the exponent of 3. Remember that. So meaning to say, in place of 64, we can write 4 to the exponent of 3. So if it is 64x to the exponent of 3, it is the same as 4 to the exponent of 3 times x to the exponent of 3. 64 is same as what? 4. So which we can write it as a single term, 4x raised to the exponent of 3, as we have got a common exponent. So we can take the 4 and x together raised to the exponent of what? Of 3. The common what? The common power or exponent. So it is just a single term raised to the exponent of 3. This is what we want. We just need something that is visible, all right? So we can rewrite this as what? 4x raised to the exponent of 3. We haven't changed anything. The cube root of 64 is what? Is 4. The cube root of this is x. So we haven't changed anything, but all raised to the exponent of 3. So 4 to the exponent of 3, 64. X to the exponent of 3, that will be this one. We haven't changed anything. Minus y to the exponent of 3. So we can just save this one to the exponent of 3. So we can properly see that the terms that we have is this one representing our x minus y representing this part of y cubed. So we have got the last term. As we can see, we can apply the equivalent identity. It is an identity under algebra, that one. It's an identity that is under algebra. So if you understand it, just apply. X minus y simply means first term minus the last. First minus the last. So what is our first term? 4x. Minus the last term, which is y. In a bracket. X minus y. Another bracket is going to be x squared. X simply represents what? The first term. So it's first term squared. What is our first term? That is 4x. So it's 4x squared, which is going to give us from our exponent, 4 is raised to the exponent of 2, which is 16. X is also raised to the exponent of 2. So it's going to be what? 16x squared plus xy, which means the product of the first and last. First and last. You multiply those two. The product of the first and last. What is our first? 4x. What is our last? That is y. So you multiply these two. First term to the last term. 4x times y, that is going to be 4xy. All right? We move on to the last part, which is what? The last term squared plus y squared. It means the last term squared, y squared. So that is our last term is y, but must be what? Squared. Just like that. We are done. This factorization, guys, has been proved to be true. That's why I'm saying you use it as an identity. You must memorize it. Expanding these brackets, you're going to have exactly what you had before if you expand and simplify. That is to show that is what? It has been proved. So this is your factorization. We are going to look into other questions, just trying to continue with what we have according to that exercise 11 that we are working on before.